Good day, viewers. This will be our sixth session on again on number system. I am going little bit slowly on number system because I think number system, as I said before, is the foundation or the backbone of at least arithmetic operations. And as I have said there, we are now going to talk about rational and irrational number. Mathematical operation on both these type of numbers. So let us say what we call about mathematical operations, just to refresh your memory and to tie up with our previous video. With this video, I will just go back a little bit. So we talk about mathematical operation is first is addition. Addition is represented as plus, subtraction is given as minus, then multiplication you do it there, and also as a star it is accepted in using computers or other applications, and then you have divisions. So division is indicated as this. Now addition, when you add certain thing, that is also known as sum, and this is also known as difference because the outcome is known as difference. This is also known as a product. Okay, what you get, and this is also known as quotient. Okay, so don't get confused. Sum is when you add two things like a plus a equal to 2a, that you indicate as sum. Whenever you say 2a minus a is equal to a, that is your difference. So a into a, that is equal to a square, that is your product. And then if you have a divided by a or a square divided by a, that is equal to a, that is your quotient. So we are very much aware of these things. I have also talked about it last time. I have talked in a different. So sometimes we will be used as addition, meaning sum, difference, product, and quotient. Now we'll see what happens in case of say rational number. In case of a rational number, what happens? All these sum, all that means sum plus difference, sum, comma, there let us call it, comma, difference, product, quotient, there also is rational. So that they are also rational. So if I take two rational numbers and do this method, two or three rational numbers and do these operations, that means 1, 2, 3, 4 operations. If I do all these 4 operations and perform, let us say perform operations, like 1, 2, 3 and 4, I shall get a rational number. Rational number. Now let us say what happens when one of these products, one of these things, instead of being a rational number, it becomes an irrational number. Now what happens to that? Let us see that. Let's do some examples which are given in the book itself. So I'll pick up that book and then we will do these operations. So let us see what happens there. Okay. Let us see, that will be in the previous page. Let us say, for example, we add root 6 plus, or let us say minus, as is given in the book, let us say with plus minus root of 6. What will this will be? So this will be root 6 minus root of 6, that will be equal to 0. So 0 you know is a rational number. So now use of two irrational number gives you a rational number. Similar thing would be minus 2 and minus this and this. What would be the result? You are subtracting. Now if there is no sign here, that means this is a positive sign. So positive root 2, I am deducting negative root 2, so I will get a 0. Okay, similarly, if I multiply, say, root 3 into root 3, or as is given in the book, that is given as a product, that is root 3, and they have not given anything, they have just given in a dot. That means this is also a multiplication, so this will be 3. So now you see the products of two irrational numbers becomes a rational number. Similarly here, similarly here. Last one is division. Root over 17 divided by root over 17. These cancels and you get 1. So that is another rational number. So operation on rational numbers are also there. Now let us see what happens about, there are two things, again we are going to do this when, that what happens when I have, as I pick up from the book, the examples I am giving in the book, so that you can, if any time you want to cross check or you want to see something, you can easily say. Now root 3, root 2, they are irrational. Let us say, what is the value of root 2? I should have written it properly. What is the value of root 2? Root 2 is 1.4142. Okay. What is the value of pi? Pi is equal to 3.1415. I am picking up the values from the book. There may be a little bit difference elsewhere. Okay, what is the value of root 7? Let us pick up a value of root 7, okay. Let's pick up a value of root 5, because root 5 has been given, that is 2.236. Okay. Now, what happens when we have 2 plus root 3? What you will do? If I can find value of root 3 would be about 1.732, like this it will be. Okay, so this, since this is a rational number, but this is a irrational number, and so there are some would be irrational. Right? The sum will be irrational. Similarly, if I take 2 into root 3, that will also be irrational. So this is a product. This product will be irrational. Irrational. Okay? Okay. I will now utilize this one. Let us say, check whether it says example number 12. Example number 12 says check whether they have given certain things. Let's check whether they are irrational or rational, whatever it is, are irrational number or not. What are the numbers they have given? 7 by root 5, that is one number given. 7 under root 5, okay. Then it has given 2 plus root 2 plus 21, okay. And it has given pi minus 2. Okay, how do we handle this? I have given value of this, okay, 2 point this thing. So it should be 7 multiplied by, so 7 root 5 would be 7 multiplied by 2.236 and non-terminating, because this is an irrational number. Irrational numbers. Irrational. Okay, so this is irrational. So if I write it, that should be enough. Okay, so if you multiply this by this one, what do you get? You get again 15.652. Then this is irrational. Irrational. ठीक है. Again, then this one. We should not keep any irrational number at the denominator. So what do? This is called, it is called rationalization. Rationalization of denominator. ठीक है ना? So how do I do this? Because this will be very difficult to have it in the number line. So I will multiply both sides. 7 root of 5. Again I will multiply by root of 5 divided by root of 5. These two are same. So multiplying the denominator and by numerator by the same number does not change the value. So what does it become? It becomes 7 root 5 by 5. We know what is the value of 7 root 5. I have done it before. So 15.652 divided by 5, right? So that will give me a value as is given. I will not go through 3.1304. Easy. Goes by this thing 7, 3. This is 3. This is 3. Okay, so now you see, but this is again an irrational number. I write now IR instead of going through the same thing. So this point is important. You will see a lot of sums on rationalization of denominator. Let us see the same next one. Next one is again easy. Next one, what you do? Some of my students say they are very, very confused about this rational irrational number, the value of pi. If they see a pi, they get nervous. I don't see what is there to be nervous about. This is very, very simple, because you treat it as a number which is irrational. People are still trying to see whether it terminates or whether it's recur at any time in future. So let us see root 2. Root 2 value we know 1.4142, and that is continuing. Add 21 to this. So what you get? 22.4142, which continues. Okay, so this is again irrational. So you see, addition, even though you are adding with a rational number, your result will be again irrational. Okay. Now the last one, let us see what it is. Pi minus 2. What is there to be so much afraid of? Pi minus 2. So you already have pi, value of pi. So 3.1 1415 minus 2 to it. So minus 2. So what will be 1.1415? Many times instead of this value of pi, we take it as 22/7, but that is an approximation. That is an approximation, but it is good enough for us to do this solution of mensuration problems and other numerical problems. Okay, now we will go, this is very, very important. Okay, now say we do something about additions, and here I have taken only single or addition of 2. Let us expand ourselves a little bit. Let us go to, let's say, go to another level. That means when we go to another level, that levels are always a little bit higher up or advanced level. Let us say it says add to, this is example 13. Example 13. So what does it say? 2 root 2 plus 5 root 3 plus 5 root 3 and root 2 minus 3 root 3. What do I have to do? First of all, I have to see combine. So these are coefficients. So I have to take this, and I have to take this and this. Okay, so if I add these two together, so 2 root 2 plus root 2, what it becomes? 3 root 2, right? This one 5 root 3 minus 3 root 3 will become what? 2 root 3. So this, what will be the value? It should be, value would be 3 root 2 plus 2 root 3. Is that okay? Okay. Now you can see the rules of addition, you can see associative, distributive or commutative comes into operation. That I can change their position with respect to each other and combine them and have these results. Okay, now again let us see, multiply again. There is another example, again small one. I'll tell you that what are the meaning of doing these examples. So first one was an addition, we did an addition. Now we will do a division, a multiplication. We will not do a division, but we will be doing multiplication. Let's say 6 root 5 by, this says multiply, multiply 6 to this thing into 2 root 5. Okay, what we get? We get simply this and this you multiply, that is 12. Root 5 into root 5, you get 5, you get 60. Now look at this. This is a rational number. Even though these two are irrational number, multiplication of these two gives you a rational number. Okay, example number, this was example number 14. Okay, next one is example number 15. What does it do? It says 8 root 15 and divided by 2 root 3. So what do? You do first 8 root 5 you write, and you write 2 root 3, right? So you do it this thing, and it is 2 root 3, and this is not root 5, this is root 15. I'm sorry. That's why it will be different. So this is root 15. So what do you get here? You get 8 into, this I can change by distributive law. What do I get? Root 3 into root 5. नीचे क्या है? 2 into root 3. I have at the denominator 2 into root 3. What does this give? This and this will cancel. I will get 4. This will cancel. So I will get 4 root 5. So now here, product of two irrational number gives you another irrational number. Okay, now what we can summarize through these things? Let us summarize a little bit. And this has been very nicely also given in the book, but let us understand what these are saying so that you would be able to understand it better and remember it better, because this is being done in your presence. So 1, sum and difference. I have already explained to you what is that the sum and difference means of a rational number. A rational number and an irrational number. Is irrational. This is okay, we have done exactly. So the sum and difference of a rational number and an irrational number is irrational. This is number 1. Okay, what is number 2? Number 2 again we will go. The product. Now the sum and the product. So product means multiplication. Product and quotient. Quotient means division. Again same repetition of a rational number and I'll go here, and an irrational number. Irrational number is what? We have done this thing will also be irrational. Okay, so this is somewhat, this thing was irrational and this other one is also irrational. Between two different, these are two different things. Okay, now comes, so this is between a rational number and an irrational number. Who wins? Irrational number wins. Okay, so that is. Now let us see what happens between two irrational numbers. So if I take two irrational number, as we have done before, that we made a product and we got 60. So in that case, in one of these examples, and that is example number 14, so I can say that sum, difference, okay, product and quotient. Now what is this? This is between two irrational numbers. may be a rational number or an irrational number, right? It may be a rational or an irrational number. This one is now very clear to you. I have now written it differently. So this is sum, difference, product and quotient between two irrational numbers, may be a rational number or an irrational number. These are drawn on the basis of previous examples. There is another very important mathematical operations that we have not discussed. We have used it, but we have not discussed it very, very carefully. And let us do that. This is called radical sign. This is called a radical sign. Radical sign. Okay, what does it mean? We know if I do this thing and we place, let us say, x. So this means square root. Okay, nothing here. There is no 1, there is no 2. There is no 2. So this is blank. This implies, even if this is, that this is a square root. Okay. Now what do I do if I write 3 here and this is x means any number. So that will be cubic root. Now if I write 4 here, that will be fourth root. So you can continue. And ultimately you can also write, here if I write n and x, so this is nth root. So nth root, you put anything, that will be nth root. Generally 1 and 1 is nothing, this is a radical sign. 2 generally is not written, nowhere, hardly you will see anybody writing 2 here, but only the square root of this one will be rowing this. So what is this means? So square root of this thing is equal to, if I write it like this, let us say again, so let us write it. What is the operation? Operation is, if this is the square root of b and if that is equal to a, so square root of b comes with a value a, then if I square on this side, then b would be equal to a square. So similarly, if I have the nth root, if I try n to the power b and that is equal to a value, then if I do it nth power, then b should be a to the power a. And of course the usual this thing that b should be greater than 0 and a should be greater than 0. These conditions will definitely remain, because this, if it is there 0, this has got no meaning. And you of course definitely know root of 1 is equal to 1. Okay, those you will all know. Okay, now let us go to the next one, and this is a little bit interesting one. And this is using geometry, how to find root of x. So what is this is done? This I will spend a little bit. This one is clear, okay? And we have been doing it. It is only being said in a different way. It is as this way, and this is the way it will generalize it, and you will be able to understand it. Okay. Now, here the book does a little bit confusing treatment which I want to settle it right. Here we are geometrically finding value of root of x. Okay, what it is done? So it is done first, let us take a number line. Okay, let us take a number line. Okay, let's say this is a number line. Okay, now on the number line, take a point A. Okay, and from here takes the value of x, जो भी x है. मान लो ये है तो आपका b, और इसके साथ 1 यूनिट डालो, whatever unit is there, 1 unit, and let it be equal to c. Okay, they are using the same thing? Yes, they are using also the same thing. अभी ये जो AC हुआ, these things, AC, this is AC, इसका half करो, make it half. That means you divide it this way, make it 1/2. Let us say it comes it here. Let us make it 0. O, not 0, this is O. Then you draw a semicircle. It will not go all the way, it will go only this way. So let me draw a very reasonable semicircle. Okay, so this is a semicircle. This is a semicircle with radius, कौन सा radius लिया आपने? AO equal to OC. From here, now draw a perpendicular all the way until it touches this graph. Okay, so this is 90 degree. If this is 90 degree, definitely this is also 90 degree. Okay, it touches. And let us call that point D. Okay, which point? This point. This point is D. And then let us join OD. Okay, this OD joining is not shown in the book, but I think this is important. This should be joined. Now let us, this now is this triangle. This triangle is now a right angle triangle with OD as hypotenuse. What is the value of OD? Is the radius, because we have drawn it with the radius. What would be the radius? Radius will be x plus 1 divided by 2. Agreed? So this is x plus divided by 2. What is this value also? AO. So OD equal to, this is equal to OD. What is OA? That is also same. XA. This is also a radius, is equal to 2. Now let us find out what is the value of OB. What is the value of OB? Because then I can use a Pythagoras theorem. OB is OA, OB is AB, AB minus AO. Agree? Definitely. This is OB and this is, and what is this OB we have taken? What is this is? Remember this. This is, I have taken it as x. Okay, and this BC I have taken it as 1 unit. This is equal to 1 unit. I said these things, but I did not mark it like this. So your AB is equal to x and this is equal to 1 unit. So let us write AB equal to x and AO is equal to AO is definitely radius, that is equal to x plus 1 by 2 minus x plus 1. This you are aware of finding it out. So let us do this one totally. So this would be, this would be 2x, right? 2 into x. This will be minus x, and this will be again minus 1. This will be divided by 2. So ultimately I will go here and I will use a different chalk. Maybe that because of some variation you will be able to do. See, so this would be x minus 1, because this minus 1 divided by 2. Now I have got all the sides. So I have to find out and what would be the value of, let us see, value of OD. I know I can find out the value of BD. So what would be the value of BD? Value of BD. Value of BD. Pythagoras theorem. This I know what is the square. So let us do. So value of BD would be what? OD square is equal to BD square plus OB square. Everybody agrees with this? Okay. So this would be value of BD. So the value of BD will be equal to this. Okay. So let me erase the top part of it, because you have already must have seen this, or you can go back, and because this is a video, you can always go back and find out what was written here. Okay. Let's now put the values of OD. What is the value of OD? OD is equal to, we have already written, x plus 1 divided by 2, जिसका whole square होगा. ठीक है ना, डिवाइड बाई 2, ये 2 को लेके होल स्क्वायर है, इस 2 को लेके होल स्क्वायर है, बी केयरफुल नहीं तो 4 बना दोगे यहाँ पे, इज इक्वल टू व्हाट इज BD स्क्वायर. BD स्क्वायर इज द वन वी वांट टू फाइंड आउट. सो BD स्क्वायर विल बी व्हाट इज OB स्क्वायर. OB स्क्वायर वी हैव फाउंड आउट x minus 1 divided by 2 इसका होल स्क्वायर. ठीक है ना. Now I need a little bit of space, and I am trying to find out where I can find a space here. So I will erase this itself, because this point has already told you what I wanted to say, and I will continue with this. So BD square would be equal to, BD square would be, this I will transfer here, x plus 1 by 2 in the whole square minus x minus 1 by 2 इसका whole square. ठीक है? Okay, okay. Now, what do I get here? I'll make a little bit. I can take, this is a square. So let us take 1/4 out. So this would be equal to x plus 1 whole square minus x minus 1 whole square. Okay. So what it would give me? Let me write it down here. This would be equal to, so I am going from here to here. This is 1/4, and you can do it either a square by minus b square. You can do it. So a square we can do it this way: x square plus 1 square plus 2 into x minus x square plus minus 1 square plus, now this is minus plus 2x. This is done. Okay. Now these and these and these and this will cancel. So I will have 1/4 x 1/4 into 2x plus 2x, that is 4x. So this gets cancelled, so I will have x. So what did I get? I got BD square. Now I got BD square is equal to, let me write it down here instead of erasing it. I got BD square is equal to x. Therefore, BD is equal to root of x. So, what is the process? If I want to do, let us say x equal to 3.5. So, I got to find out root of 3.5. How would I do it? I will take here x, wherever I have taken x, I will take it as 3.5. I will take this one as 1 and I will go through the same process and find root of any one of these things. And remember, this is my number line, okay? So if I want to put it on the number line, I'll put this one here, take it here and do it like this. So this will come down as my number line. So this will be there. So there will be no problem putting any one of these things on the number line. Okay, so this is over. I don't think there is any controversy on this one. This has been done, and I will also take up little bit of other things, and we'll discuss with some of these examples that is given, and it is very easy, very interesting to remember them. Some of these things you need to practice a lot and memorize, because in an exam it is not only the correctness of the sums are important, how fast you do it, that is also important. Remember, if there are 10 sums and you will end up doing 7 only, so you will get marked for that 7. You will never get 10 out of 10. So you have to attempt correctly all the time, and there is a time which is given, and that time is given for everybody. Okay, let us say what would be the square root, cube root of 8. You know it is 2. What would be the, say, fifth root of 2, 4, 3? That would be 3. Why? Because you can multiply, you can do it easily. See this one? It should be 3 into 81. That would be 3 into 3 into what would be here? 27. Okay. So again there should be 3 into 3 into 3 into 9. Again that would be 3 into 3 into 3 into 3 into another 3. Okay, so 1, 2, 3, 4, 5 threes, and we have been asked for this. So let us start writing down 5s here, 5s here. So you will end up equal to 3. But looking at this, sometimes you don't get confused. So this is a process of factorization. Remember, you have been taught factorization quite before in one of videos in my channel. You can go through the factorization process. This is in the polynomial section, and that will give you a very good exposure on factorization, and that we are using here. Okay, now there are little bit, as we have said, about the radical sign we have talked about, and let us say this one. Let us say some of the, again we have done identities before in a section on polynomial. Similar identities are there also with respect to numbers with radical signs. So let us take what happens here as it has been given in the book. This is given as AB. So we can use the law of distribution, and we can write this one root A into root B. Many students get confused here. There is nothing in it. And let us say you write it by another one, A by B. Let us say you are given like this, root of A by B. So there is nothing but you can distribute this. You can write root A by root B. Okay, remember this. Many people get confused. How do I do it? How do I simplify it? And what are the kind of things that we have been doing? So similar to identities before, again there are the total list. I will go through some of these lists, and then we will we'll close this presentation and pick up in the next. So let us say A plus root B multiplied by, there is nothing, root B minus root A minus root B. So there is nothing means multiplication. I have repeatedly told you there is no sign between two brackets. That means this is a multiplication. So what is it would be? A square minus B square. A plus B into A square minus. So it should be a root A square minus root B square. So that will be A minus B. Right. Now we can say, do it on the same vein, and we can do A plus root B. These are all from the book. You can check this one up. Minus root B. So this would be A into A. This would be A square. This would be A square minus B square. So this would be B. So looking at this, you can easily find out what would be. Remember, these two, this is irrational number, this is an irrational number, you are getting a rational number. Same thing here, two irrational number, products of two irrational number, you are getting a rational number. Okay. Now let us continue a few more, and then in our next video we will take up the rest of the one. And this one is root A plus root B multiplied by root C. See, these are all multiplications, and root D. What it would be? Again this thing, root AC plus root BC plus root AD plus root BD. No problem here, root AC, root BC. Again, another one, time tested this one, root A plus root B, and that is whole square. A square, that would be A, B square, that would be B, plus 2 into root A into root B. Or you can also write out down A plus B plus 2 into root of AB. Okay, so we have done our this thing. We have completed many things. Still a few remaining, and this I will be able to complete in our next video. I will again request you to like my channel, to like this video, and also subscribe to my channel. Good day and have a nice time.